Hello and welcome to today's review of Chi-square testing. Okay, so we're looking at Chi-square testing. What are the pieces that you would be required to do within an AP exam test problem? So now, the first thing that we want to think about is there are two types of chi-square tests. And try to think to yourself, what are the two possible types of chi-square testing? Okay, the two that we have are the goodness of fit test, and we'll see when we use that one versus a test for independence. And the main thing that you're looking for here is the type of data that you have overall. In a goodness of fit test, what you have is a single variable, and it's the color of the toy. Whereas in a test for independence, we're talking about two separate variables, type of soft drink and the gender of the individual. Okay, so there is a small difference here. Goodness of fit is talking about a distribution of one variable. A test for independence is talking about the independence between two variables. Now, one thing that we always have to consider is our degrees of freedom. We find degrees of freedom by looking at our number of categories and cutting one off of every possible variable that we have. So in a goodness of fit, you're just cutting off your last category, gives you your degrees of freedom of 4, where when we're looking at this test of independence, we cut a variable off of both categories. Notice we don't look at the totals at all in that situation, and we see what we have left for the value we're looking for. Okay, so there's 1 degree of freedom in that 2 by 2 situation. Okay, now the one thing that's different about chi-square tests than any other is really the hypotheses. Okay, there are usually no numerical values put into your null and alternative hypotheses when we're looking at a chi-square setting. So if you're looking at a goodness of fit, what your null hypothesis is that whatever distribution we're looking at are either equally distributed, match some percentage breakdown. Okay, so we're looking at those individual values overall. And the alternative is whatever distribution you're looking at does not match, is not equally distributed, does not match the percentage breakdown given to us. Okay, so it is a statement about the goodness of fit. We're assuming that it fits what we're told, that typical pattern, and we're trying to prove that it does not fit that pattern. Okay, when we're talking about a test for independence, what we're doing is we're looking at our two variables, and what we would talk about is the top and the side categories. Soft drink choice and gender are independent. And then your alternative is soft drink choice and gender are not independent, are dependent. Okay, so we're always assuming independence, okay, because it is the test for independence, and we're trying to prove that they're dependent on one another. Okay, now what assumptions do you have to test? Okay, we're starting with chi-square. It's an easy chance to kind of dip the toe in the water. We'll look at the proportional and mean value testing in a review coming up. But when we're looking at chi-square, okay, number one, we always want to state the type of test we're doing. Okay, we can build this into our assumptions, or we can use this as a part of our null and alternative, but it has to be somewhere on the page. Now, when we're looking at our individual assumptions, okay, we need a simple random sample. Okay, hopefully it's stated somewhere in the problem. You want to write the sentence from the question. You don't want to just say SRS check mark and I'm done. Okay, that's not enough to get credit, and that will cost you points if you do that. write the sentence from the question where it says simple random sample, and even throw the size in. You know, simple random sample of 200 individuals. Now, the other piece that we need is our expected counts table. We have to show the expected values, and once we have those expected values, we use that to prove the assumption that all of our expected counts are greater than 5. So you need to show the individual table. So now, let's talk about how we can build that expected counts table by going back to some of our original tables we have here. Okay, this is my observed table for each. Okay, observed table for independence, observed table for a goodness of fit test. When we're looking at goodness and fit, we want to add up those values. So we've got 10, 18, 20. And when we're looking at a goodness of fit, we always need the total of the table. And then we're going to break this 20 down based on some distribution. Now, if they say that everything is equally distributed, okay, then we would have our expected table equally distributed, 20 divided by 5, so we would have 4 each. Okay, so notice in this situation, it would violate that second assumption where the expected values need to be greater than 5. That wouldn't stop your work, okay, but it would be something that you would want to note as you moved on through the rest of your problem. Okay, now, expected values for a two-way table test for independence is given to you by the calculator, and we'll show that how it gives it to you in a little bit. But I also do want to show how you can get an individual expected value using a two-way table. To get that individual expected value, what it is the proportion of the row, 25 over 50, or 1/2, of the total value. So we need to use these three values to get that one expected value. So we've got 1/2 because it's equally distributed male and female. So of those 21, half of them should be male and half of them should be female. Same thing here. Okay, so it's always based on the proportion of the row totals, and then we use that proportion to break up the column value into its two parts. And it might not be equal parts. In this case, it was equal. But if we had some other situations, we could easily see that it would not be equal between the two. Okay, now, what calculations do you have to show? Because anytime you're doing a hypothesis test, understand that this is a 4-point question. If you're null and alternative type of test assumptions, those things fit into 2 of your points out of 4. So you've already got half of your points by the time we're to this calculations page. Now, the calculations you have to show that you can use the chi-square formula. You only have to show a couple values in using the formula. Okay, so using the 2 tables that you have, your observed and expected, plug in a few values here using the formula, and what you do is we're just looking at chi-squared equals, and I'm just going to make up some observed values from that one. 6 minus 4 squared over 4 plus 2 minus 4 squared over 4, and then plus, or dot, dot, dot. Okay, you have to do that. The calculator can actually find the chi-square value for you. You just have to show that you can use and input values into the formula. And then you also have to show a probability statement. Once again, the calculator is going to give you the probability, so you're going to fill in this number, okay, but you do have to write the probability statement and show what the value equals. Okay, now, like I said, the calculator will do everything for you. You just have to know where to go. So for all of our tests, we want to go into Stat button, okay, over to test. Okay, and if you have the newer operating system, you should have both options there for you. So you've got your chi-squared test and your chi-squared goodness of fit. Okay, this first one is your test of independence. Notice that it tells you that you need two matrices. You actually only have to fill in matrix A. It will make matrix B for you. So if we go to our matrices, okay, we don't have any matrices entered in, but we'll put one in quick, edit. We'll just do a quick 2 by 2. 4, 5, 6, 2. Now we've got that matrix in, and we would actually just go right back to stat, test, chi-squared independence. Okay, so we've entered in that matrix value. Now we're going back to the independence test, and it's just enter all the way through. Okay, it finds the chi-square value for you, your p-value, your degrees of freedom. And now some of you are saying, okay, I need that expected table. Where is it? The expected table is back in your matrices. It was put into matrix B for you. So here are your expected values that you would put into your assumptions page. Okay, now, if you're wanting to do a goodness of fit test, we actually need our data list. Okay, so once again, let's say that all these values are equally distributed. Okay, we've got 20, 37. Okay, so 37 divided by 1, 2, 3, 4, 5, 6. Okay, so we're going to go 6 each. We're going to give 7 to 1, just to make life a little bit easier. So now we've got our observed and our expected columns in here. We go into stat, test, and we want to do chi-square goodness of fit. Okay, and the nice part is as soon as you select the type of test, it will tell you what information you need for that. Now, the one thing that we have to do is define our degrees of freedom for us, okay, to make sure that we have the correct value. Now, we just happen to be lucky here. Degrees of freedom was 5, but it doesn't naturally set this for you. You have to be able to define the degrees of freedom for the problem. And then we can go into calculate, and there is all of our values. We've got our chi-squared value of 5, we've got our p-value, degrees of freedom, so we have everything we need in that spot. Okay, now, last thing that you need for any test, okay, you've got your null and alternative, type of test assumptions, that's the first half. The second half of the problem is your calculations. Show your work, even if the calculator is doing it for you. You have to show you use the formula. And then what we have to do is write our conclusion. Conclusion needs 3 parts. You got to state your evidence. Based on our p-value, 0.41, compared to our significance level of 0.05. If they don't give you a significance level, always just revert back to using 0.05 for that value. Okay, number 2, make a decision about the null hypothesis. If your p-value is below, you're going to reject the null. If your p-value is above, you're going to fail to reject. And then the last piece is you're going to make about a statement about the alternative in context. Okay, so if your p-value is below 0.05, it does support the alternative context or the alternative hypothesis. And you have to write that entire statement in sentence form using context. Now, if your p-value is larger than your significance level, then it does not support the alternative hypothesis, which states, and then you want to write everything out in context. Okay, so that was a brief review of chi-square testing. Thanks, and have a good day.